All right, so as you're finishing that up, we're going to get on 3.2 here, continuing to talk about these tables. And you're going to notice a couple different options here. Sometimes it will list percents and sometimes it will give you just the numbers. There is a difference between them. Okay, so the first question says, notice and wonder. So take a peek at that. Give me one thing you notice. If you're willing to share, just raise your hand, please, and one thing you wonder. Just based on that first chart. Noah? Notice anything? Notice anything?
Both columns add up to 100%.
Both columns add up to 100%. Georgia?
4% of the teachers have an associate degree.
That's what you notice? Yep. Okay, what do you wonder?
Why is that percent?
Why are they listing percents?
How many teachers?
How many teachers were surveyed? Doesn't tell you that. Maybe you're wondering what that would look like if you just did Valley City High School, as far as degrees go. So again, questions like that, as long as you explain, can't really get it incorrect.
What degree do you have?
I have a master's degree.
What's the difference?
Bachelor's is usually a 4 or 5 year degree, like at Valley City State. And then if you go back to school and beyond that, it would be a master's degree. I got my undergrad, bachelor's in town here, graduate school master's I got at Minot State.
How many years of college was that then? Like 9?
No,
6?
I spent 5. I double majored
Oh.
to get a 4-year degree and then 3 summers to get a master's degree. All right, so question number 2. 200 people were asked if they prefer dogs or cats, whether they live in a rural or urban setting. Actual values collected are shown below. So 200 people, you can see all their answers are listed. Now on top of the next page, they show it a different way.
So what's rural and urban?
Rural is like country, urban would be city. The next table shows what percent. So again, they have it listed in a different way. Now let's see if we can figure out where those numbers came from. How did they get 27%? And we're gonna make a little note of that. So using the chart on 14, the previous page, how do you think they got 27%? 54 divided by 96 is 56%.
54 is 27% of 200.
Yeah, so 54 divided by 200. Remember those 200 people that were surveyed? Make a little note of that's how we got 27%. Remember, percent would be part out of the whole thing. In this case, it's part out of 200. That's our entire people that were surveyed. So how'd they get dog at 40%? Here's proof that it is 27.
So you don't do anything with like total number of cats and dogs?
Nope, not yet.
80 divided by 200. It's like
80 divided by 200. 80 said dog out of 200. This would be the same. That'd be 42 out of 200 and 24 out of 200. All right, the next table changes a little bit. And now it's asking about certain pet preferences in a column. Based on the graph and the table again. So now we're not basing it off of 200 people anymore. It says we're dealing with the column. So how did I get 40% for the cats?
54 divided by 134.
54 divided by 134 is correct. That is the urban column. Dog would be the same. That would be the 80 divided by the 134. That would be what percent of the urban pets are dogs. How would I get to 64 following the same pattern?
42 divided by 66.
42 divided by 66. And 24 divided by 66. And that would be part over the column total, is how we got those. Everybody got that before we turn the page? Okay. Says last table shows a percent of each row. So looking back, you'll have to flip it now. How do you think they got 56%?
Oh,
Say that again?
54.
54 divided by 96.
54 divided by 96. Yes, we're taking part divided by the the row total. Is how they got these percents. 77 would be 80 over 104. 42 out of 96. And 24 out of 104. Okay, it says for each relative frequency table, select a percent, explain how we got the numbers. Well, we did that. We listed them on each chart. We showed how we got those numbers already.
How do you know what, like, graph to go to when it asks you a question?
Well, that's what we're going to discuss right now.
Okay.
Question number 2, then you decide which one we're going to go to.
How do you know?
What percent of those surveyed live in an urban area and prefer dogs?
Oh, wait, 60.
Okay, so it says out of them surveyed. So how many total people were surveyed? 200. So it's not based off of just urban, rural, it's off of everybody. So the question was asking how many prefer dogs. So how many total people prefer dogs? 104.
Wait, how'd you get that?
Live in an urban area and prefer dogs, sorry, not just dogs, urban and prefer dogs. 80? So what percent is 80 out of 200?
40.
40% is correct. Among the people surveyed who prefer dogs, so now it's narrowed down to just people that like dogs. That's our denominator. What percent of them live in an urban setting? So again, I'm going back to the original here.
Okay.
People that just prefer dogs, how many total? 104, that's my denominator. And of those 104, how many live in an urban setting? 80. So what is 80?
7%.
80 80 divided by 104. Yeah, we just did that one up on top, right? Is that how you got that so quick? It's right here. What percent of people surveyed, again, so what's our denominator? 200. Oh, sorry, I didn't read the whole question here. What percent of the people surveyed who live in an urban area? So how many lived in an urban area? 134. Gotta complete the sentence there. How many of those 134 prefer dogs? 80? 60%? That must have been on one of our charts. What percent? All right, how many of the people responded that they prefer dogs and live in an urban setting? So this is out of everybody again. How many people pick dogs and urban? 80. Nope, it just says how many people on this one. Gotta be careful what the question is asking. Among the people surveyed, are there more people who prefer dogs or cats? Dogs. All right, your pet food company has access to a billboard in a rural setting. Would you recommend advertising for dog food or cat food? Which table did you use? And why? So rural setting.
Oh, wait, yeah, cat.
Yeah, so you could look at the original. Also tells you right here, 42 out of those 66 people in the rural prefer cats. So I would say the bottom table on page 15 or the original one would be fine. I agree, I'm gonna advertise for cats. Because 64% of the people that live in the rural area have cats. Page 17 says, in an experiment to test the effectiveness of vitamin C on the length of colds, 2 groups of people with colds are given a pill to take once a day. The pill for one of the groups contains 1,000 milligrams vitamin C. The other group is taking a placebo pill, so they don't know that it's not vitamin C. The researchers show the results. Again, the first thing I would add to any of these, whether you will need it or not, is a total. Total going across. Next one. For a total of?
113.
Total of group A?
33.
Group B? All right, so again, that's the first thing I would add. May not need it. Number 1, Georgia, why don't you read that one, please?
First, the researchers want to know what percentage to the nearest whole percent of people are in each combination of categories. 14% of all the participants had a cold that lasted less than a week and were in group A. What percentage of all the participants had a cold that lasted less than a week and were in group B? Complete the rest of the relative frequency table with the corresponding percentage.
All right, so they took 16 divided by the total and got 14%. So group B, we're going to take 27 divided by the total. So 27 divided by 113 is about 24%. $17 divided by 113 is about 15%. And the biggest group, 53 divided by 113, is about 47%. Now, it might turn out that it does not equal exactly 100. We are rounding those to the nearest percent. So realize it might be from 99 to 101. Question number 2. Jackson, would you read that one, please?
Next, the researchers noticed that among participants who have had colds that lasted less than a week, 37% were in group A. Among participants who had colds that lasted a week or more, what percentage were in group B? Complete the table with the corresponding percentage.
All right, so they got the first one by taking 16 divided by 43. How do you think we're going to get group B?
27 divided by 80. Or, yeah.
27 divided by, not 80,
32, and
43.
We lie.
Because 43 is our row total.
But they do column total.
They did not, they did 16 divided by 43.
Oh, sorry. 43.
All right, and we probably could have already guessed this, right? If this is 37%, they have to add up to close to 100, right? 63%. Can also get the 1 underneath there. This would be 17 out of 70. %, and now we should be able to get this one as well. 76. Notice when you're dealing with percents, because we're going across this way, this is what will add up to 100. Obviously, this way does not, because we divided everything by the totals going this way. All right, question 3. Samira, would you take that one, please?
Finally, the researchers noticed that among the participants in group A, 48% had cold that lasted less than 1 week. Among the participants in group B, how many had the colds that lasted a week or more? Complete the table with the corresponding percentage.
All right, so now they're doing the column, 16 divided by 33. We should be able to estimate the bottom one already. It would be 17 divided by 33, which will be 52%. So now they will equal 100 going this way. Group B would be 27 out of 80 for 34%. Last one is 53 divided by 80 for about 66%. Okay, let's see if we can answer questions now using these charts. To understand the results, the researchers want to know, among people whose cold lasted less than a week, what % are in group B?
34.
Okay, so less than a week, so I'm looking at the column. How many of those were in group B?
27.
Out of? 27 out of 43. 27 out of 43. Again, we already have that figured out right here. 63%. And you can use the original one or the second table for problem number 2. Shows us that. If the researchers believe that vitamin C has a small effect on the length of cold, which group most likely got pills containing vitamin C? So vitamin C has a small effect on how long your cold lasts. Do you think group A got the vitamin C or group B?
Wait, is the vitamin C the cold last a week or more?
So this group of people, some of them got vitamin C or a water pill.
Oh.
One of them could be this one as well. So if vitamin C helps your cold, do you think that got given a group A or group B?
A,
Why?
because there's smaller numbers in group A.
Yeah, a smaller percent had a longer cold in group B. So I agree with that. I would say group A. A smaller percent had a longer lasting cold. Okay, 52% of the people had a longer cold. Group B, 66% had a longer cold. So that would be the last table that would help us with that. Again, you can always revert back to the original. Last thing I want to just touch on is when you are comparing these, which the Are You Ready wants you to do, what do you notice about these two charts? And it's talking about some computer programming. One's called Python, one's called Scratch. But if I'm going to make some comparisons, what is my issue here? What would make it difficult to compare? What do you notice about the charts? Yeah, exactly. It's hard to compare apples to oranges here. One's a percent, one is just a total. Okay, so when you do that, you either need to make them all numbers, like the top one, or all percents like the bottom. Okay, so let's just practice that. I'm going to add a little total column here on the bottom. So 25 people were surveyed here. So if I would want to make this one percents, I would take 8 divided by 25, which is 32%. 6 divided by 25, which is 24%. 1 divided by 25, which is 4%. 1 divided by 25, which is 4%. 7 divided by 25, which is 28%. And 2 divided by 25, which is 8%.
How'd you do all that in your head?
Just took them times 4 because there's 4 quarters in a dollar. I think you could have done the same. And let's say you wanted to change these to numbers. It does say there were 20 kids surveyed. Over here on the previous page says 20. So out of 20, how many of them would be 25%? 5? How many would be 0? 0. How about 5%? What divided by 20 is 5%?
So then 1.
1. How about 30?
Sure.
Yeah, so every person, when you have 20, every one correct is 5%. So how many 5% does it take to get to 35? And then you could double check, make sure you got a total of 20 people. So either make them all percents, that's the point, and compare, or show how many you have. Now in this case, because you did not survey the same number of people, percents is probably smarter. Okay, because just because you have a higher number here of 7 and a 7 here, that does not mean the same thing because you did not survey the same amount of people. So I would probably compare percents. If you look at the top one, Where's the highest percent at? Which column and row?
34 and 30.
Top chart.
Oh,
8 is the highest percent?
40%. 32.
32% is the highest.
Why?
That's the highest percent. That's a 4. 28, 24, 4, and 8. 32 is the highest.
But wouldn't,
So most people in the 8th grade said they've been taught and they know Python. Is that the same for the seniors? No. They still say they have been taught it in school, but now they know Scratch programming the best. So again, I would compare the percents. All right, a couple more examples. Those are called relative frequency tables. They can be helpful. Some people might find them more confusing and just prefer the original, and that's fine. Okay, that's fine. Your assignment today is 6 questions. Yeah, but they do take up some room because of the charts. Just make sure if it's asking for a percent, you answer percent. If it's asking you for a number, you do so as well. So that is it for today. Lesson 2, page 22 to 26.